This is a review for benchmark 4, and it has to do mostly with problems that deal with unit 4. If you want help with any of the other units, any of the old stuff, for the other 15 questions, go ahead and look at any of the other 3 review videos to help you. So here we have triangle PQR. It's an isosceles triangle, so that means 2 sides are congruent. And it tells us that PQ is congruent to PR. So it's important to read these directions and label on the picture which sides are congruent. So PQ and PR are congruent. That means the angles across from those sides are also congruent. So Q and R must both be X. Now we have something for all of the angles. They should all add up to 180. And we can just solve this equation. So this is the equation that we can write to find X, and we can solve it, making sure that you do all the steps right. And you get that X to 65. If you didn't label these right, you might get that X is 50. I'm sorry, you might get that X is 80 if you assume that R is 50. But you need to make sure you read the directions and see which sides are actually congruent to each other. Here we're looking for the measure of angle B. We have this triangle here, we have 2 angles labeled, so we can figure out what this angle is. We'll call it X for now. So 62 plus 83 plus X, they should all add up to be 180. Subtract 145 and we get that X is 35. So that means if this angle is 35, then so is this one, because these two are vertical angles. So now I have 2 of the 3 angles over here, so I can do the same thing. 35 plus 68 plus question mark is 180. And I can get that missing angle, the measure of angle B, is 77 degrees. So we use twice the idea that all the angles add up to 180. Here's a problem that looks similar to one of the pods we did. I have 2 remote interior angles right here. They are remote from this exterior angle. And the theorem says that these 2 remote interior angles, if we add them together, like so, they should be equal to the exterior angle that they are remote from. So now we've set up an equation. All we need to do is solve for X and plug back in for the appropriate angles. So I combine like terms. I get 28X plus 10 is equal to 26X plus 20. And we get that X is 5. That's not our answer though. We want the measure of ABC, which is this angle right here, ABC. So we can find that a couple ways. The way that I'm going to find it is by plugging in for X and finding this angle and knowing that this angle, that's 26X plus 20, and the angle we're looking for are supplementary. So this angle that's 26x plus 20 is 150 degrees. And since this one and the ABC are supplementary, we know that ABC must be 30 degrees. Here I'm told that the two triangles are congruent. I'm looking for the measure of A. So I have all three angles here, 32, 58, and 90. I can go see which angle corresponds to angle A, and it will match whichever angle that is. So A corresponds to E. E is 32 degrees, so that means the measure of angle A is also 32 degrees. So corresponding parts are the same, they're congruent. A and E are both 32. This problem is a little tricky. Let's see what we're given, that W is congruent to Y, so I'm going to show that. And we're asked to say by which theorem. That's what we mean by why are these triangles congruent, by which theorem. So we have side, side, side to choose from. We have side, angle, side. We have angle, angle, side. We have angle, side, angle. And we have hypotenuse, leg. So we're going to see if we can show that these two triangles are congruent using one of those 5 theorems. Well, we don't know that these are right triangles, so our hypotenuse leg is out right away. We have a pair of angles that are congruent. And remember, the reflexive property tells us that this side is the same in both triangles, so it's congruent to itself. That gives us one side. So I think probably we can eliminate side, side, side. These arrows, and this one's supposed to be on the line, mean that these two lines are parallel, these two segments, XY and WZ. So we can go back to our parallel lines unit, and if I extend all of these lines to make a picture that maybe we're a little familiar with, I can see that I have two parallel lines and a transversal. So I might have some congruent angles. So because these two lines are parallel and I have this transversal, I can see that this angle and this angle are congruent. So I have another pair of congruent angles. So I have two pairs of angles, so I think side angle side is out. Let's see if it's angle angle side or angle side angle. In order for it to be angle side angle, the side has to be in between the angles. It has to be included. So right now I have this angle W and angle Z, and my side is not the side that's included. It's not forming both of the angles. So I need to eliminate angle side angle as a choice. So my answer would be angle angle side, angle angle side. Here I want to classify the triangle by sides and angles, so that means I need to give it two different names, one based on its sides, one based on its angles. I notice right away that I have two congruent sides. So by sides, I can say it is isosceles. This angle is 43. That makes this angle 43 because of the isosceles and the congruent sides. So this angle I can find quickly by knowing all the sides add up to 180. And I can see that this angle is 94. 94 is an obtuse angle, so that makes this an obtuse triangle based on its angles. Here I have two congruent triangles. I'm looking for the value of x, and I can see that angle D corresponds to angle B. So I know angle B is 30, and angle D is 2x plus 10, so I can simply write an equation that says they are equal because they correspond in congruent triangles. And I can solve this two-step equation. And find that the value of x is 10. Pardon me. Here I am looking for x. I know that this angle here, that's 42, is congruent to this angle. They're vertical angles, so that makes this one 42 as well. These three should add up to 180. You might be seeing a common theme here. So all I need to do is solve this equation. And you can find that x is 28. I think this was a problem of the day, or at least we did this in a review game or Anchor, one of the three. I know we've seen this problem before. We want to find the theorem that shows these two triangles are congruent. Remember, we have a pair of vertical angles. We are given a pair of angles are congruent. We know a pair of angles are congruent because they're vertical. And we're given a pair of sides. So I have angle, angle, side, because that side is not an included side. These two triangles are congruent by angle, angle, side. Here again we're given some information, A congruent to H, so I need to show that. I also know just by looking at this picture that MT is congruent to itself. It's congruent in both triangles. We want to know the theorem that shows these two triangles are congruent. We're also told that segment MT is a angle bisector of AMH. That means it bisects this angle. So it means that these two angles are congruent to each other. So I have a pair of angles, another pair of angles, and a pair of sides. The side, again, like the other ones, is not included. AM is the included side, so I have these congruent by angle, angle, side. Here I want these triangles to be congruent, so I'm trying to find the coordinates of N and K. So I can find the lengths of these sides, and they should be congruent to the lengths of the other sides given the coordinates. So I might have to do some distance formula work here. Or I can see that if I start at P, I have to go to the right 5 to get to R, and up 1. So from 0, 0, I go to the right 5, and I go up 1, and that gets me to R. If I do the same thing here, I go to the right 5 from 8, that gives me 13. And if I go up 1 from 5, that gets me 6. So there's K. I guess that's probably easier than the distance formula. Here I go up 2 to get the Q, and I go right 8. So I'll do the same thing here. Up 2, that's 10. To the right 8, that's 13. And I have the coordinates for N. So you could do distance formula. I think that's a lot easier. I think we just did this one in our review game, but we'll do it again. I have an isosceles triangle, so these angles are congruent. That means they're both 12x minus 6. All three of them add up to 180. The trick here is to make sure I combine my like terms correctly. 12x plus 12x is 24x. Negative 6 minus 6 plus 48 gives me positive 36. And I believe 24 goes into 144 6 times. So x is 6. Just a reminder that you can find the other 3 reviews on my YouTube page, and they will help you with the first 3 units. There'll be 15 questions on those.